we are in class number 5 of signal and system. Okay. So here there is one question. A signal e to the power minus alpha t sin omega t is the input to a real linear time invariant system. Given k and phi are constants, the output of the system will be of the form k multiplied by e to the power minus beta t sin nu t plus phi, where there are four alternatives about beta, alpha, beta, omega and nu. So which one of the given alternative is correct one? And this question has been asked in GATE 2008. It is given that the system is the real linear time invariant system. Okay, real time invariant system. So for the system to be time invariant system, what we need, if this is xt, suppose xt, it is given that xt is equal to, xt is nothing but, xt is given that xt equal to how much, e to the power minus alpha t, okay, sin omega t, okay, and yt is, so this is input, and yt is k e to the power minus beta t sin nu t plus phi. So for this system to be a linear time invariant system, so for the system to be a time invariant system, y t minus tau must be, means the delayed output must be equal to, if we apply the delayed input. So if we apply the delayed input, then the output found must be equal to yt minus tau. Okay, the delayed output. Okay, so both of them must be equal, and this is only possible if yt is a function of xt. If yt is a function, and you can say if yt is some constant multiplied by xt, and there should not be any multiplication in t. Okay, so this is only possible. So this system, let me write, since this system is linear time invariant, and it is only possible if yt is, suppose some constant, let me write that constant as lambda. Okay, lambda multiplied by xt. Okay, lambda multiplied by xt. So lambda is what is? Lambda is some constant. Then only, sorry, this is t. Then only it will satisfy both linearity as well as the property of time invariance. Okay, otherwise it will not satisfy. So for this, for the given system to follow this equation, what we need? We need that this nu must be equal to omega, because this phi is some constant, and this beta must be equal to alpha. Okay, and for this, for the above system to satisfy, or you can say for the given system to satisfy the above relation, we must have how much we must have? So we must have omega equal to nu and alpha equal to beta. Okay, and if this happens and if this happens, then we can say, or we can write lambda equal to nothing but lambda will be how much? K angle alpha. Okay, K angle alpha phi, sorry, K angle phi. So K is constant, phi is constant, so both are constant. So this is only possible when this relation will hold. That means that is omega equal to nu and alpha equal to beta. So which one of the given options is correct? Beta is equal to alpha and nu is equal to omega. So option number C is the correct one. Okay. The next question is the impulse response of a causal linear time invariant system is given as st. Okay. Now consider the following statement. Statement 1, principle of superposition holds. Statement 2 is st equal to 0 for t less than 0. Which of the following options is correct? So there are 4 options, and this question has been asked in GATE 2008. Okay, so the question is about the impulse response of a causal linear time invariant system. Okay, is st. So the impulse response of a causal linear time invariant system is st. So if the system is causal linear time invariant, though, so definitely st will be 0 for t less than 0. So statement number 2 is correct one. 2 is correct. What about statement number 1? Principle of superposition holds. It is given that it is a causal linear time invariant. Since the system is at first it is causal. So since it is causal, that's why the statement will be true. Since it is linear also, because the system is linear, so principle of superposition will also hold. So statement number 1 and 2 both are true. True. So which of the given option will be correct? So option number D will be correct one. Okay. The next question is let a signal A1 sin omega 1 t plus phi 1 be applied to a stable linear time invariant system. Let the corresponding steady state output be represented as A2f omega 2t plus phi 2. Then which of the following statement is true? Okay, so this one there are 4 alternatives given, and it is asking about the function function f. What type of function f should be? So it is given that input is how much? A1 sin omega 1 t plus phi 1. Okay, and the output is nothing but A2 f omega 2 t plus phi 2. Okay, and again it is given that the system is a stable linear time invariant system. Okay, since the system is linear time invariant system, so output must be a function of input, as we have seen in the previous question, I think question number 20. So here also the output must be some constant multiplied by the input, because only then the property of linearity as well as time invariance will be established. Okay, otherwise that property will not hold. So this output must be some constant. Suppose this output must be some constant. Let me write it as this must be or let me write, this must be some constant, suppose lambda multiplied by xt. So suppose this is input is I have taken input as xt and output as yt. Okay, so the output yt must be lambda where lambda is some constant. This is some constant. So lambda multiplied by xt. Okay, and this is only only possible because these phi 1, phi 2, a1, a2, these all are constants. So we don't have to bother. We have to bother about only omega 1 and omega 2. Okay, since these are variables. So this is only possible if f is a sinusoidal or cosinusoidal function. If it is a cosinusoidal, then also we can make that as sinusoidal. Okay, because there is a relation between sinusoidal and cosinusoidal. There is a phase difference between sinusoidal and cosinusoidal function, and that is only pi by 2. So we can make any sinusoidal function as cosinusoidal and cosinusoidal function as sinusoidal. So both of the functions, whether it is sine or cosine, both are called sinusoidal function. So f2 must be a sinusoidal or cosinusoidal function, and these omega that is omega 1 and omega 2 must be equal. So for this to happen means for the system to be linear time invariant, or for the system to be linear time invariant, f must be sinusoidal or sine or cosine function. With omega 1 equal to omega 2. Okay, then it is only possible. So which of the given options is correct? So option number D is correct. Okay, the next question is, a control system is defined by the following mathematical relationship. This is the mathematical relationship. The response of the system as t tends to infinity. So the response of the system is asking, and there are 4 alternatives given, and this question has been asked in GATE 2003. And the response of the system as t tends to infinity, or you can say the final value of the response is asking. So if we take the Laplace, this is the equation governing the mathematical equation governing the system. So if we take the Laplace transform of both the sides, then we will have, and since it is not given, the initial conditions are not given, so we assume that initial conditions are 0. So here we can write s square xs plus 6xs plus 5xs, okay, and that equal to 12, and this will be 1 by s, and this will be minus 1 by s plus 2, because e to the power minus 2t is associated with this. So now we can write here, this will be s square plus 6s, okay, 6s plus 5 multiplied by xs, and here 12, and if we take s into s plus 2 as LCM, then s plus 2 minus s will come here, and it will be 24 divided by s into s plus 2. Okay, now xs will be nothing but 24 divided by s into s plus 2 multiplied by s square plus 6s plus 5. Okay, now the question is asking about the steady state value, or you can say the final value. So x t equal to infinity, okay, that is also called a steady state value, and that will be equal to limit s tends to 0 s xs, okay, and that will be limit s tends to 0, s multiplied by 24 s into s plus 2 s square plus 6s plus 5. Okay, so s will cancel out each other, and if we put s equal to 0, then the first in first bracket 2 will be left, and in second bracket only 5 will be left. So 24 divided by 2 into 5, that is 10. So 24 divided by 10, and that will be equal to 2.4. So the correct option is option number C. The next question is, let ST be the step response of a linear system with 0 initial conditions. Then the response of this system to an input ut is. There are 4 options given, and this question has been asked in GATE 2002. Okay, so ST is the step response. A step response means when we give the step input. So we can write ST as, ST is nothing but, so ST is nothing but it is convolution of what is suppose transfer function, or you can say the system is the impulse response of the system is HT. So ST convolution, okay, ST convolution, the step input. So if we denote the step input by suppose u dash t, so u dash t, okay. So let me write what are these terms. So ST is impulse response of the system, and u dash t is a step input, or you can say a step function. Now if we take the Laplace transform of both the sides, then it will give SS equal to HS multiplied by this will be 1 by s, because the Laplace transform of unit step function is 1 by s. So now we can write HS is nothing but s multiplied by SS. Okay, now HS is nothing but s multiplied by HS. Now if we give the input ut, okay, then the output will be the Laplace transform of output will be, so if we give the input as ut, then the Laplace transform of output, how much it will be? So it will be nothing but, suppose output we can write output as CS. So CS will be nothing but, this is nothing but transfer function HS. So HS multiplied by the Laplace transform of US. So S into let me write HS multiplied by US, where US is the, here US is the Laplace transform of input. Laplace transform of input. Okay. Now we can write CS as nothing but, HS is nothing but S into SS. Okay, S into SS multiplied by US. Okay. Now if we take the inverse Laplace transform, and since there is no initial condition, so it will be CT will be equal to nothing but d by dt of Laplace inverse of SS into US. Okay. And what is the Laplace inverse of SS into US? It is nothing but it is convolution of ST into UT. Okay. And since UT is a input, that is UT is a causal and causal input, so the integration will be from 0 to t. Instead of 0 minus infinity to infinity, the integration will be 0 to t. So now we can write this as d by dt of how much? S t minus tau, okay, u tau, d tau. And since input is a causal function, causal and you can say time limited function, so it will be from 0 to t. Okay. So which one of the given options is correct? So option number B is correct one. Okay. I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video. If you subscribe my video, then there will be no need to search the new videos. Automatic update will come to you when I upload the new videos. What you have to do? It is very simple. There is a circular logo containing my photo is coming in right of me. You have to just click on that for subscription.